Hello my dear students, welcome to one more amazing session from Infinity Lane by Sri Chaitanya. This is Suresh, Faculty of Chemistry. आज हम चर्चा करने वाले हैं thermochemistry, the most fascinating topic in the thermodynamics, especially for the students preparing for NEET examination. I could say whenever thermodynamics comes, it's all about numerical aptitude and you just quickly leave this because of the fear. So at the end of the session, I am going to unveil this fear, and fear is no more, your fear is on us, and you can expect one question from this thermochemistry. So in the journey of the NEET examination preparation, 4 marks will be in yours, and I am going to give you simple tricks and tips to solve thermochemical equations. Whatever it is so complicated, looks so complicated now, I can tell you one simple thing about thermochemistry and their calculation. It is simple definition based numericals. So can you believe it? You can just crack this question by using a simple definition. Yes, a few examples are there, and if you check the last 10 years question papers, NEET examination thermochemistry questions can be solved by using just definition knowledge, mind it. So no worries, I'll be here to mentoring you about this thermochemistry. All the best my dear students. Before I start the session, please like this session and share with your friends. इन लोगों के भी फ़ायदा होना चाहिए, and subscribe to NEET Infinity Lane YouTube channel. So dear children, before going for this thermodynamics, it's all about application of thermodynamics first law in chemical equations. So these chemical equations could be a endothermic reaction or exothermic reaction. So enthalpy of a reaction is the key point to say that. Hi Guruji, how are you? Those students who are online, please, it is a live interactive session. You can talk to me and I can talk to you, and use the chat box generously, and we can do the best. And it is not a radio telecast session, right? Dear children, let us start. Before going for the starting, I just want to introduce the score examination. Anant, hi. How are you? So what is a score examination? Score examination is India's largest scholarship examination. Why I should claim this is India's largest scholarship exam? Yes, it is pretty simple. We are the unicorn. Sri Chaitanya Academy is the unicorn in the education industry, and we are coming up with a score examination. And why this score examination? Because Sri Chaitanya Academy want to hunt for, search in the bright minds like you. For that, we are offering a score examination. Any student from grade 3 to grade 11 can write this examination. And you know, this score examination, based on your performance, 2.5 crore of cash rewards will be given, and 350 crore scholarships are given. And so have you ever dreamed to go to NASA, United States of America? Here still we are ready. NASA trips are also will be taken to encounter this space research and space shuttle programs and all, and it is on us. Those deserved students, a group of students will be taken to NASA trips. It will be on us. Okay, so at the age, a small age, we are going to NASA, that too by Sri Chaitanya, mind it. And also exciting gadgets like tablets and laptops will be given, and up to 100% scholarships will be given based on this performance that you got. So no worries, we can do it, and all the best. The registrations are open in the description box. The link is available, and you can click it and register yourself. This examination conducted twice, September 28th and October 12th. And September 28th examination you can enroll up to 26th, and October 12th examination you can enroll up to October 11th. And this examination can be written by any student. You may be a student of Sri Chaitanya, you may be a student of any other private or government schools, and still you are eligible to write it. Hi Jarha, how are you? And this examination you can write offline as well as online. Okay, so for offline you can go to any nearest Sri Chaitanya Academy, and can you enroll yourself. Depending upon the availability, date will be given to you. And Violet, you just click the link available in the description box, and you can do the best. All the best my dear students to get as many as goodies. Okay, fine. And going into the NEET So you're all preparing for NEET examination. For this NEET examination, I just want to introduce 𝒑𝒂𝒂𝒊𝒕 Academy and Infinity Land is going to give you the NEET test series. Why this test series? If you're writing any examination, it is required to know where exactly you stand and what is your improvement areas, what is your strength. For that, a scientifically designed assessment platform is required. If you ask any one of your seniors, those who are in the toppers, and they say they prepared like you sincerely and they did hard work and they did the NEET test series from any other source. So that is a secret to become a topper. And we are from Infinity Land by Sri Chaitanya is offering the NEET test series. It is the ultimate key to NEET success. And it is separately designed for this grade 11, grade 12 and repeaters, droppers. And this gives you, based on the latest NTA pattern prepared by these expert faculties from the Infinity Land and Sri Chaitanya Academy, and it gives the simulation, real-time test-taking experience you are going to get it. When you attend the real-time actual NEET examination, you feel as if it is a regular practice. That is a secret, and you will be doing the best in your NEET examination. All the best. Late description box link is available and the pinned messages also. You can do the best. और एक चीज़ है, when you purchase this now, you simply add YouTube 30 off coupon code. When you do this coupon code 30 off, automatically you will be getting 30% off on the package. Okay, Jara, do it, and all the students, all the best for your NEET test series and all. Now moving into the thermodynamics, my promotion is over. Let us go into the details about the thermodynamics and the thermochemical principles. Okay बच्चों, thermochemical equation, ये thermochemical equation कहना चाहता है क्या? I just want to say carbon plus oxygen gives rise carbon dioxide. This is a chemical equation. It is a balanced chemical equation. उसमें state भी दिखाना चाहिए. So carbon, which is a solid, let us say it's a graphite, and it is a gas, and it is a gas. And you know one thing, during this combustion process, some amount of energy is released, that is called heat. How much heat is released? So you need not have to memorize any value beta. जो भी value है required, ये question में दिया जाएगा आपको. So never and ever strive to learn the values. So it gives the relief to the entire mindset. है ना? Guruji, Anant and Zara. And follow, I think Betu has to come into the class. Okay, let us follow. I am giving you क्या करना, क्या ना करना. Right? Okay, so thermochemical equation is going to give you the total balanced chemical equation along with the physical state or allotropic forms along with how much heat is released. That is what is called thermochemical equation. So which of the following is actually thermochemical equation you need to know, and what is the key point we need to understand in that. So thermochemical equation gives us information like energy changes and physical state changes and the transformation that changes. And you can say this can be written like this: 393 kilojoules of heat is released. Carbon, which is in the graphite, and it is combined with oxygen in the combustion, which is in the gaseous state, gives rise carbon dioxide, and which is in the gaseous state. Along with that, 393 kilojoules of heat is formed as one of the product. So those students who are in 11th standard, you understand this. Let it be some value. So I remember that value. As a teacher, I am giving you this value. Okay, how do you do this? So heat is released. This is the heat is released. So this heat released is written in the form of the enthalpy. So that is called exothermic reaction. Exothermic reaction. So I want to say this is a carbon in graphite physical state. Allotropic form has to be introduced, and oxygen in the gaseous state gives rise carbon dioxide in the gaseous state, and semicolon is given here, bachcho, semicolon is given, and the delta H value is going to be exo. So the system is losing energy, so that delta H is going to be negative 393 kilojoules per mole. So this is what exactly the technically thermochemical equation. Jara, any doubt, bachcho? I am telling you, no, you need not have to memorize this value, right? And why this is negative? Why this is a positive? So if you add money to your bank account, so accountant will write plus. If you withdraw money from the account, so account loses money, so it will be written minus. Similarly, here exothermic reaction is given a negative sign, endothermic reaction is given a positive sign. So I just want to say endothermic reaction are those chemical reactions which absorb energy. So delta H is going to be positive value. Endo mean to say going in, endothermic reactions. Okay, absorb in, right? Are you getting or not? Absorb in, okay. And exothermic reaction, it is endothermic reaction, exothermic reaction are those chemical reactions which released, I mean to say heat is going out and heat is going in, coming in and going out. Therefore, ताकि इसका delta H value negative quantity होगा. Okay, that's very important. और एक चीज आपको बताना चाहता हूँ. So let a hypothetical chemical reaction A plus B gives rise C plus D, and delta H मान के चलो ये माइनस x किलोजूल होगा. अगर ये रिएक्शन उल्टा करने तो क्या होगा? सो मैं क्या कहना चाहता हूँ, C plus D gives rise A plus B. अगर रिएक्शन उल्टा होगा तो डेल्टा H मैग्नीट्यूड वही रहेगा, लेकिन इसका साइन ऑपोजिट रखना चाहिए. सो दैट डेल्टा H इज इक्वल टू प्लस x kilojoules. समझ में आ रहा है क्या? दिस इज वेरी इंपॉर्टेंट एंड इट्स फिनोमिनल. इफ यू नो दिस ना, यू कैन डू द बेस्ट फॉर वेरियस thermochemical equation related questions. So the key point in the thermochemical reaction is this. If you want to write this is ये reaction आधा कर लो. So yes, this reaction I just want to make it half. Half A 1 by 2A plus 1 by 2B gives rise 1 by 2C plus 1 by 2D. So delta H कितना होगा? फटाफट बोलो. डेल्टा H कितना होगा? फटाफट बोलो. I want to know. Heat release नहीं हो मतलब mean to say जरा heat can be released out or can be going in. Certain reactions heat may not be released also. Such reactions are called thermoneutral reactions. जैसे reactions होगा chemistry में, ऐसे reactions rarest of the rarest condition में होता है. ठीक है बेटा? At least thanks for asking the doubts in the live class. I really appreciate asking the doubts during the live class. So इसका क्या होगा? डेल्टा H इसका क्या होगा? जल्दी बताओ फटाफट. डेल्टा H कितना होगा इसका? जरा those who are online, please let me know your opinion over here. So delta H is equal to minus x by 2. I want to say if the reaction is divided or multiplied, you are going to get the x value, the delta H value in the same version. समझ में आ रहा है क्या जरा? Anand and Guruji, those who are online, I want to just be interactive in the chat box, and we are going to conduct these classes for the real time NEET preparation. Okay, you take a pen and paper, write these noteworthy points. ठीक है, noteworthy points, and be interactive. To have such kind of classes, you need to go to A coaching center pay huge amount of money, travel together, hours together, waste time, waste money. Here in the YouTube channel, and expert faculties are coming and discussing the topics with you at the NEET level. It is completely free of cost. हम बच्चों लोग को कुछ भला करने का कोशिश कर रहा हूँ. Support us, so you don't have to pay anything. Simply sit in the class and write noteworthy point and attend our class. And please like the session and share with your friends. Subscribe to Infinity Learn NEET YouTube channel बच्चों. And मैं कुछ बदलना चाहता हूँ यहाँ से, and ये वाला थोड़ा सा डबल करना चाहता हूँ. So 2a plus 2b gives rise to 2c plus 2d. इसका डेल्टा h कितना होगा बेटा? जरा I want to know इसका डेल्टा h कितना होगा? जल्दी फटाफट करके बताओ. Okay, if you have doubt then you can ask us. Yes, tell me. If you divide the equation by 2, you are going to be x by 2. If you multiply the equation with 2, you are going to get minus 2x. So और एक सवाल है आपका, और एक सवाल है. So let us say, if I want to ask you, if 2c plus 2d gives rise 2a plus 2b, इसका डेल्टा h कितना होगा? अभी बताओ, अभी बताओ. If you divide the equation by n number of times, you are going to get the delta h value is divided by n. If you multiply the equation with n, so delta h value also be multiplied. I just want to say that is going to plus 2x. फिलहाल कुछ डाउट होना तो आप पूछना. एक जरा it was minus 2 and it is going to be plus 2. See the conditions. And if I leave A, B, C, D, let us take the real time things like N2 plus 3H2 gives rise to NH3. No, sorry, learn the things. Sorry बोलने के लिए नहीं, हमारा क्लास सीखने के लिए, प्रैक्टिस करने के लिए. Okay, practice along with me. Stay tuned in the class. I am going to take you to the next level of this thermochemical equation. शुरुआत से I am going to discuss these things. Stay tuned. I just want to discuss here for a chemical reaction. So this is what is called enthalpy of reaction. Enthalpy of reaction. So this is the enthalpy of reaction, means in any chemical reaction as indicated, I just want to say the enthalpy of reaction, जिसमें reactant product होगा. Okay, reactant is going to be converted into product. So A plus B gives rise to C plus D. उसमें ये reactant होगा and you are going to get a product, है ना? So enthalpy of a reaction, I mean to say how much energy is released due to this reaction or how much energy is absorbed due to this reaction is equal to enthalpy of reaction, can be calculated simply by taking the sum of the enthalpies of the products minus sum of the enthalpy of the reactants. Product minus reactant, हमेशा product minus reactant होगा. Okay, in the entire thermochemical equations, in the entire thermochemistry, product minus reactant, that's it. If you apply the same fundamental anywhere, your problem is solved. One condition, जब bond energy आता है ना, reactant minus product, ये exceptionally you have to take that. So everywhere except that in the total thermodynamics, product minus reactant. That is the simplest trick I want to say. Okay, so you say I don't want to give you the long lecture. Let us see. So this enthalpy means, what is enthalpy, what is internal energy? Let us go into the first law of thermodynamics. So according to first law of thermodynamics, heat neither be, and heat means energy, energy neither be created nor be destroyed, rather it can be transformed from one state to another state. Okay, so This change can be calculated by change in internal energy. What is internal energy? Versatile post, hi beta, how are you? And please like the session. Those who are online, please like the session. So first law of thermodynamics आपको बताना चाहता हूँ, that is delta U is equal to Q plus W. Of course, let us say U is called internal energy. Internal energy. So let us see the nature of internal energy. Internal energy is the heat present inside the body at a constant volume, inside the system at constant volume. But when it comes to the nature, in the nature almost all naturally taking processes or reactions are against to constant pressure. So I want to calculate the heat of a system at a constant pressure. So enthalpy is going to be heat of a system at constant pressure. Internal energy is the heat of a system at a constant volume, है ना? So ये दोनों में अंतर क्या होगा? So enthalpy is equal to internal energy plus PV work done. PV is equal to nRT, P delta V is equal to delta nRT. So if delta nRT is very important, if you understand this applications of first law of thermodynamics in your hand. Okay, bachcho. So what is delta N? Delta N is a difference in the gaseous number of moles minus product minus gaseous number of reactants. That's what I want to say. Okay, delta N is equal to sum of the number of moles of gaseous products. हमेशा मैं क्या बोल रहे हैं ना, products minus reactant होगा ना, sum of the number of moles of gaseous reactant. So you have to identify this. Only in the gaseous state you have to take. In this, अगर delta n 0 होगा तो क्या होगा? Delta H is equal to, ये 0 होगा तो ये दोनों बराबर होगा ना. Who said NEET examination is so difficult? NEET examination is require presence of mind, little common sense and basic subject knowledge. You need not have to be a book bugger to be a topper in the NEET. Okay, simply stick to the fundamentals. NCERT is your all, NCERT is your all, and you can do the best and you can be a topper in the NEET examination. Zara, yeah. So इसका कुछ एग्जाम्पल देना चाहता हूँ. देखो, अगर हाइड्रोजन गैस and hydrogen or iodine gas gives rise to HI, which is in the gas. ठीक है? Now और एक एग्जाम्पल देना, अगर if delta n is greater than 1, ताकि इसका delta H should be greater than delta U, है ना? इसके लिए थोड़ा सा एग्जाम्पल देना चाहता हूँ. PCl5 which is in the gas state, or decomposition gives us PCl3 which is in the gas state plus Cl2 which is in the gas state. इसका डेल्टा n कितना होगा? डेल्टा n कितना होगा? जरा versatile post अनंत and गुरुजी come on, डेल्टा n इसका कितना होगा? You calculate 1 plus 1 minus 1 is going to be positive 1. Based on this, direct numericals are there. And देखो और एक चीज़ है, and I want to give you one more example बेटा. Okay, अगर डेल्टा n less than 0 होगा तो ताकि डेल्टा H should be less than delta U. Delta U is internal energy. बेतु राधे राधे, आप कैसे लेट आए क्यों आज? I was expecting you to come into the class. आज कुछ लेट है. Okay, बेतु come on, a reaction delta n less than 0 आने के लिए मैं एक और एक एग्जाम्पल देना चाहता हूँ. नाइट्रोजन which is the gas, 3 hydrogens which is a gas, and gives rise to NH3 which is a gas. Okay, and इसका डेल्टा n कितना होगा बेतु? जल्दी बताओ, जल्दी जल्दी. जी नहीं, ओके, नो प्रॉब्लम. या लेट है चीनी, कम ऑन, इसका आंसर डेल्टा एन इसका कितना होगा 4 जरा ओके फॉलो, प्रोडक्ट माइनस रिएक्टेंट है ना जी नहीं, प्रोडक्ट माइनस रिएक्टेंट, प्रोडक्ट क्या क्या चीज है 2 moles of NH3 are there na and 1 mole of nitrogen is there, 3 mole of hydrogen is there. विद्या शेट्टी 1 + 3 होगा, मान के डेल्टा एन इसका -2, अगर डेल्टा एन पकड़ने तो क्या होगा आपको, राइट? जस्ट अ मिनट, so is my voice is audible now बच्चों, is my voice audible? Vidya, find it, okay. Now let us talk about this. So enthalpy of reactions. So enthalpy change can be calculated for all reactions. Let it be, the reaction could be in a combustion reaction, that reaction could be formation of some compound, the reaction could be some hydrolysis reaction, some neutralization reactions, any reactions. Betu, now we can say enthalpy change can be calculated for sometimes called as the heat of a reaction. In generic version it is called as a heat of reaction. So we have enthalpy of reaction. So enthalpy of reaction is equal to sum of the enthalpies of the products minus sum of the enthalpy of the reactants. So in that version, that reaction could be formation of a compound. So it is said to be enthalpy of a formation. Simple, one shot many birds. Generally we say one shot two birds, no? I say one shot many birds. So I want to say here enthalpy of formation. It is the heat absorbed or released. Okay, absorbed is in the case of endothermic reaction, released in the case of exothermic reaction. Okay, when 1 mole of a compound is formed, because that is called formation, right? It is formed. कहाँ से form करना? Elemental substance से form करना, uncombined state से form करना. That is the condition. Now you can see, I want to say enthalpy of combustion of you see carbon which is in the graphite and oxygen which is in the gaseous state gives rise carbon dioxide which is in the gaseous state. You can see this reaction delta H is equal to -393 kilojoules. So this value is telling combustion of graphite and also formation of carbon dioxide, because 1 mole of carbon dioxide is formed from its elemental substance. You know, one flexibility is given for thermodynamics now. The thermodynamics can give you the enthalpy of formation of uncombined elements is always 0. I want to say enthalpy of formation of oxygen is 0. Enthalpy of formation of carbon in the graphite allotrope is going to be 0. Enthalpy of formation of bromine in the liquid state is 0. Enthalpy of formation of sulfur in the rhombic state is going to be 0. Enthalpy of combustion of phosphorus in the white phosphorus is 0. Enthalpy of formation of H plus in the aqueous state is 0. You know one thing, enthalpy of formation of carbon in the diamond is not equal to 0, but graphite is 0. So thermodynamics taken, yeah, iron it is 0, zara. Enthalpy of formation, standard enthalpy of formation of iron metal is going to be 0. H naught means it is standard condition. Thermodynamics by 1 atm and 298 Kelvin is said to be standard. It is going to be standard state. Okay. And here this is very important, only one thermodynamics is taken only one allotrope because of the experimental reasons as a 0. The other allotropes are not taken as a 0, mind it. As iron don't have an allotropes, it has only one state is going to be 0. Right, G? Very good. Now, you can take here enthalpy of combustion. Combustion process hota hai kya? Combustion means burning, burning of an element, complete burning. So, the enthalpy of combustion is the combustion of 1 mole of a substance completely. The enthalpy change, means the heat released, is called as enthalpy of combustion. CH4 plus 2O2 gives us CO2 plus H2O. Enthalpy of combustion is minus 890 kilojoules. So, the major problem with the student is when this equation is shown, you focus here. Don't focus there. You focus on what is happening. Don't focus on the number. Rather, you focus on its magnitude. I mean to say, it is a negative or positive and how much approximately. And it is called enthalpy of combustion of methane is this much, right? And this enthalpy of combustion is always exothermic process because the combustion releases heat. And also enthalpy of solution. What is the meaning of enthalpy of solution? When 1 mole of a salt is dissolved in excess of solvent, it is going to be dissolute. During that process, heat is released. That is what is called as an enthalpy of solution. Most of the cases, enthalpy of solution are endothermic process. Vidya Shetty, sir, can you give some tips to solve complicated questions in chemistry at last? Definitely, I am going to give you. Stay tuned in the class. Hope you understand Ginny and Vidya, Betu, Jara. The way I am explaining is helping you or boosting the subject. Betu is regularly attending the class since long when the Nirman series is started. She is gaining a lot of knowledge during the sessions. Betu, is it right? And she is also maybe 1 or 2 classes she missed due to ill health. So, we got connected on the YouTube platform, right? So, you enjoying sessions, Betu? So, I want every student should enjoy the class, right? Vidya Shetty, come on. Now, in this case, enthalpy of solution you are going to see minus 91.211. Okay. Similarly, various examples are there. Enthalpy of hydration. So, it is the energy released or absorbed when 1 mole of anhydrous or partially hydrated salt undergo hydration. Yes, hydration means water molecules are surrounding around the ion is called hydration or addition of crystalline state to water. I mean to say anhydrous copper sulfate, na? You just add 5 water molecules to become copper sulfate dot 5H2O. It was white in color, become a blue in color. Now you are going to see this is what is called as enthalpy of hydration. In the NEET examination, ये enthalpy of hydration का बारे में थोड़ा सा complicate करते जाते हैं by adding some technical terminologies. No. So 5 water molecules are not added at one time. Gradually 1, 2, 3 is added up to 5. That is called integrated enthalpy of hydration. Okay, enthalpy of neutralization. This is a very, very important beta. And based on this, you can write one question. You can simply solve. And this is the enthalpy of neutralization. The heat released when 1 mole of an acid or 1 equivalent of an acid is completely neutralized by 1 equivalent of base in a large excess of dilute solutions. Okay, this is what is called as enthalpy of neutralization. So, what happened here? Enthalpy, any strong acid, you can say any strong acid combined with a strong base gives rise salt plus water. So, strong acid H plus देते हैं, strong base OH minus देते हैं, दोनों मिलके H2O is formed. फिलहाल में क्या बोल रहे हैं आपको? Don't memorize any value. Here the value comes to be delta H of the neutralization is going to be minus 57.3. You please memorize this value. Please memorize this value. Please memorize. So I believe 100% this value will be given when the question comes into the exam. If not given, so at least you memorize this value. For any strong acid on any strong base, मैं क्या बोलना चाहता हूँ here? ये weak acid and a strong base gives rise to salt and H2O, and delta H is going to be greater than or less than. It is going to be less than minus 57.3 kilojoules. Why so? ये weak acid जो है ना, ये ionize करने के थोड़ा सा energy input करना चाहिए. So if you have any weak acid or any weak base is participating in such reactions, I would say delta H value is less than minus 57.3. And you just see, you get the value and subtract from this 57.3 and you are going to get some value, maybe 2.5 or 3.5 kilojoules. That is the energy is used for ionization of the weak acid or a weak base. From there also you can calculate good number questions. There definitely NEET examination questions can be given. Alright. So let's say here acetic acid plus sodium hydroxide. Acetic acid CH3COOH plus sodium hydroxide gives rise CH3COONA plus H2O. You know delta H value. Let us assume this value is you can say 50.3. Let us say dummy value. So ionization energy value of this CH3COOH is going to be 57.3 minus 50.3 is going to be 7.0 kilojoules hoga. So that much amount of energy is used to break this acetic acid. ठीक है? So you can use any fundamental aspects of this thermodynamics and you can calculate it. So as Vidya Shetty is asking, sir, can you give me some tips to solve complicated questions? Now I want to address the word complicated. What is the meaning of complicated? If you don't understand, now looks complicated. If you understand, now looks simple. So the generous answer, Vidya, it all depends upon how extent you understand the question. Okay, so complication and simple question, a complicated question is a perception. If you understand this question, you feel that question is easy. If I don't understand, I feel that question is complicated. Agree? And even easy and difficult also comes in the same way. So mind it, it is going to be the way. And talking about Hess law of constant heat of summation, it is a super awesome thing. Hess law of constant heat of summation. Here let us say A. Look at this. A is giving rise to B, D, and it is going to have heat Q. Let us say the other way. A is giving to B, B is giving to C, C is giving to D. So it is going to give you Q1, it is going to give you Q2, it is going to give you Q3. Now it is going to give Q is equal to Q1, Q2, Q3. So I want to say here Q1 plus Q2 plus Q3. Bas, itna hi hai. So this is what is called as a Hess law of constant heat of summation. The heat of reaction is the same whether the reaction takes place in a single step or a multiple steps, is called as a Hess law of constant heat of summation. Understand? Now let us see here a simple example I just want to show you. Carbon plus oxygen gives rise carbon dioxide. This is the root 1. And I want to take this root 2. First, carbon is combining with oxygen gives us carbon monoxide, and this is the step 1, and carbon monoxide combined to oxygen to gives us carbon dioxide. So here the energy released when this root 1 is equal to the sum of these root 2, and root 2 has 2 steps, no? So this is how we will do the questions based on this S law of constant heat of summation. You can see, let us say enthalpy of reaction in the root 1 is going to be minus 393.5, and in the root 2 in the first step is going to be minus 110.5, and in the second step minus 283.0. Look at this working. So the total enthalpy change for the root 2 is equal to minus 110.5 plus minus 283.0 is equal to 393.5 negative. The same thing you are going to get, na? It is experimentally verified. It is experimentally verified. ठीक है? Any doubt? Zara, Vidya, Beto. Now let us solve some questions based on this. So using delta H naught, enthalpy, standard enthalpy of formation data in the enthalpy cycle. So given the following data, calculate the enthalpy change for the reaction. A reaction का enthalpy change हम calculate करना. Fe3O3 plus 2NH3 gives rise FeO plus H2O plus N2. So substance Fe2O3, this is Fe2O3, yeah? Yes. And its enthalpy of formation is given, and use these values, and FeO, its value is given, and NH3, its value is given, and H2O, its value is given. So enthalpy change for this value is going to be our target. You can do by various ways. You can use various sources of the materials. The same question is given in a different versions of the solutions, but I am going to give you the best out of it. Okay, in this best you can see the same reaction here. Fe2O3 plus 2NH3 gives us FeO plus H2O plus NH3. In this case, arrows must show the direction of the reactions according to the data given, right? And this is the direction, or else you can use the other way. Fe is combining with oxygen gives us Fe2O3, and Fe and H2 combined with oxygen gives us H2O. Fe combined with oxygen gives us FeO, and nitrogen combined with hydrogen gives us NH3. So in this case we have delta H data for this all, making every substance that is here. So we can use this. So this is the first version, root 1 and root 2. Let us say root 1, that is Fe2O3 plus NH3 gives us FeO plus 3H2O plus N2. Mind it, the reaction should be balanced as given, right? Now you are going to see Fe2 gives rise Fe2O3, so that 2 irons and 3 824, 2 into minus 46, and in the root 2 in the same way you are going to get 6 into 266 and 3 into 286 from the given data. Where these numbers are coming, these are the numbers. It is a skill of analyzing the data and using the data, nothing more than that. Analyzing the data and using the data. So let us use this calculation. Betu, you got minus 110 or plus 110? Let us see here. So let's see the calculation part. Fe2O3 plus 2NH3. So 3 into Fe2O3 का data दिया ना, and 2 into NH3 का data दिया ना. So you are going to see Fe plus 4 half O2 and N2 plus 3H2 and 6 Fe plus 4 and half, means so 6 into 266, 3 into minus 286. So that FeO plus H2O plus N2 is formed. Simple एक ही chemical reaction टुकड़ा टुकड़ा करके अलग अलग रख ले. Now we are going to see, as Betu said, it is plus 110. That is a super awesome and outstanding answer. What do you say? Outstanding answer. ठीक है? Clear? Now one more exam you can do it, and Hess law of constant heat of summation, based on that I would like to say Born-Haber cycle also, it's very important. So one more question we'll do it, after this we'll discuss about the Born-Haber cycle, right? So from this data, look at this, calculate the enthalpy change of hydrogenation of methyl acetaldehyde. So acetaldehyde का दिया -1167 and hydrogen का दिया -286 and CH3CH2OH ethanol का दिया -1367. I am expecting you try your way and take a minute and get the answer. Just a countdown, just giving you 2 minutes. Those who are online, please like the session. Please like the session, share with your friends and subscribe to Infinity Lane NEET YouTube channel. बच्चों कर रहे? So I'll wait and meanwhile you can ask a doubt. जरा बेतु विद्या शेट्टी जीने. Yes. So this is the data of CH3CHO -1167, H2 -286. This is enthalpy of combustion values, no? And this is CH3CH2OH and 1367. You can also do not this and that way. Enthalpy of combustion values are given by enthalpy of reaction is going to be sum of the enthalpies of products minus sum of the enthalpies of the reactant. Use this simple trick and product क्या होगा, enthalpy of the CH3 CH2OH acetaldehyde, so CH3 CH2OH and CH3 CHO plus हाइड्रोजन. ठीक है, एंड इसका वैल्यू कितना दिया -1367, CH3CHO का 1167 plus it is going to be -286. Now this is your answer, -86. Yes, Beto, this is your answer. And one thing I want to say, here minus is given, here minus is given, here minus is given. You are adding 2 minus here and you are subtracting 2 minus over here. So like that, sign conversion gives you a lot of mistakes in real time examination. Take care of that. Real time examination में so आपका क्या कितना मिला, so the same thing it is written and the same way you are going to get, and the difference between these two you are going to get, it is -86. Betu doing an excellent job over here. Betu doing an excellent job over here in the same way. Understand? Any doubt? You like these presentations? Written everything in a sequential wise, right? Okay, आगे बढ़ना चाहता हूँ and I want to discuss something. Yeah, the standard enthalpy change for the neutralization can be calculated by using here the calorimeter. In this thermometer is incorporated in this coffee cup calorimeter, and insulated polystyrene cup with lid and 50 milliliters of HCl and 50 milliliters of sodium hydroxide both added by the volumetric pipette, and how much temperature is changed. So delta T has to be calculated from this, enthalpy of neutralization is calculated. Okay, so anyways, by using Q is equal to MC delta T, Q is equal to heat released, M is equal to total mass of the solution per gram you can take. C is the specific heat capacity of the solution, delta T is equal to T2 minus T1. And I just want to say Born-Haber cycle is very important. Students has a lot of confusion in this Born-Haber cycle. So let us discuss about this Born-Haber cycle here. If you talk about lattice energy, what is the meaning of lattice energy? Lattice energy is the energy that is released when, let me talk about this. One more slide you will take here. Lattice energy. So that is indicated by Le. What is the meaning of lattice? Ionic solid. 1 mole of ionic solid is formed like NaCl, which is a solid. It is formed from its constituent gaseous ions. So the energy released when 1 mole of ionic crystal is formed, ionic solid is formed from its constituent gaseous ions, is called as a lattice energy. Delta H is going to be minus lattice energy. So the lattice energy is the energy released when 1 mole of ionic solid is formed from its constituent gaseous ions. So you can't get this ion in the free state in the gaseous state. That's the reason why we use Born-Haber cycle. This Born-Haber cycle is the application of Hess law of constant heat of summation. In that I just want to say, sodium, which is actually a solid, combined with the chlorine, which is a gas, gives rise NaCl, which is a solid. To form 1 mole of ionic solid, just I require half mole of this, right? So this is a direct step. This is called enthalpy of formation. This is called enthalpy of formation. Let us use this in the different versions. What is this? Sodium is sublimating, and sodium in the gaseous state should be formed. This process, you say it is a sublimation. This is what is called sublimation. Delta H1 you can say. Enthalpy of sublimation. And let us see this chlorine, it is doing dissociation to get 1 mole of chlorine atom. This process is called atomization. It is going to be delta H2. And once you got this sodium in the gaseous state, let us make into the sodium in the place in the gaseous state. The process, you say, it is ionization. So this is going to be delta H3, right? And let us add some electron to this, 1 electron to this, so that you are going to get Cl minus. This is called electron gain energy. So it is supposed to be a negative quantity, okay? And you know, this is what is called as delta H4, right? And these two are now ready to form. Sodium chloride crystal. So this is what is called as delta H5. That is called lattice formation. That is called lattice energy. This is what is called as a lattice energy. Now, sum of this Q is equal to, I want to say, just simply apply Hess law of constant heat of summation. You can see the colors also, delta H1, okay, and delta H3, and delta H3, delta H4, and delta H5. and all the values will be given, one of the value will be missed. You can calculate that one value which is missing during this type of questions. Definitely you can expect any question this type of things. Hess law of constant heat of summation is the key point and a game changer for this Born-Haber cycle. ठीक है? Any doubt बच्चों? वे तो take a screenshot of this Born-Haber cycle. Take a screenshot of this Born-Haber cycle. Taken 3, 2, 1. Okay, this is all about the Born-Haber cycle. And bachcho, here bond dissociation enthalpy. And bond dissociation enthalpy, whenever 1 mole of bonds a type is taken and you break it and convert into its constituent gaseous atoms, that energy is called as bond dissociation enthalpy. I want to say here, the energy needed to break the bonds of 1 mole of molecule is called bond dissociation enthalpy of a substance. So more the bond dissociation enthalpy, stronger is the bond and more is the stable, and it is defined per mole of the molecule, like bond dissociation energy of hydrogen is 436. So enthalpy change of a reaction can be calculated based on bond dissociation enthalpy. मैं पहले बोल चुका हूँ. So delta H is equal to sum of the enthalpies for the bond broken minus sum of the enthalpies of the bond formed. So a chemical reaction में reactant is converted into product. So during this process, old bonds in the reactant has to be broken and the new bonds in the product has to be formed. So that I want to say enthalpy of reaction should be equal to, very important, sum of the enthalpies of the bond dissociation energy, BE. BE stands for bond dissociation energy or bond energy of the reactant minus sum of the enthalpies of the bond energies of the product. Dear children, here always in the thermochemistry, in the total thermodynamics, product minus reactant ही होगा. But in the case of bond energy, reactant minus a product होगा. And it is only one exception you can see. Why? Because during the course of these, old bonds are broken and new bonds are formed. And bonds of broken energy minus bond formed is equal to give you the enthalpy of a reaction. That gives a solid identity about is it a exothermic reaction or endothermic reaction. Okay. So we'll do some questions in the future also based on this, and this gives you very, very important thing, bond dissociation enthalpy, and here enthalpy of atomization. It is simple. If it is a diatomic molecule, it is said to be enthalpy of atomization. So resonance energy, it is also from the bond dissociation energy. If you say this is a benzene, in this benzene it is resonating, and this is what is called as a, another structure. This is what is called as another structure, and these two are the resonating structures. And what happens, you know, resonance hybrid comes to be like this. So the energy of this, one of the resonating structure and the resonance hybrid, the difference between these two is called resonance energy, and that can be calculated enthalpy of formation, actual, experimental. This is called experimental, and this is calculated, I mean to say theoretical. So this gives you the resonance energy. You know, the resonance energy is a key changer in the entire chemistry, organic chemistry especially. Stability of the molecule, is directly proportional to रेजोनेंस एनर्जी. जिस मॉलिक्यूल का रेजोनेंस एनर्जी ज़्यादा हो उस मॉलिक्यूल का स्टेबिलिटी ज़्यादा बढ़ जाता. अंडरस्टैंड. और एक चीज़ है, एंड मोर द नंबर ऑफ रेजोनेटिंग स्ट्रक्चर्स, more will be the resonance energy. Like that you can do so many awesome things in the organic chemistry based on this resonance also. Stay tuned for our organic chemistry classes also going to be scheduled after in the month of September. Stay tuned. Okay. Now hope you like this session. Betu and Zara Vidya Shetty, and we are done for today, and we will be doing in the next class about all physical chemistry points is completed, chemical kinetics is completed, thermodynamics completed, and electrochemistry is completed, and basic concepts is also completed. और क्या बचा हुआ उसमें? Yes, we are go and get NEET examination. That is your organic chemistry is going to be scheduled in the next September. Okay, we are done from our side. Please like our session, share with your friends, subscribe to Infinity Lane NEET YouTube channel. Thank you. Bye bye. God bless you. Signing off, Suresh, Faculty of Chemistry from Infinity Lane. Thank you. See you.